When we talk about scary things in space, people always go straight to black holes, or supernovas, or planets where it rains molten iron. But nobody talks about the moons, and honestly, that's a mistake, because right now, in our own solar system, there's a moon being slowly torn apart by its own planet. There's a moon that orbits backwards, and scientists believe it's a captured prisoner from the outer edges of the solar system, slowly spiraling toward its death. There's a moon that was shattered into pieces and somehow reassembled itself, and to this day, nobody fully understands how. And then there's Io, a world so violent, so relentlessly on fire, that a scientist once said, and this is a real quote, "Io makes Dante's Inferno look like another day in paradise." These aren't distant exoplanets millions of light years away. These worlds are right here, in our backyard. So let's go meet them. Let's start with the one that earns its title every single day. Io is the third largest moon of Jupiter. From a distance, it looks almost colorful. Yellow, red, orange, white, like someone painted it. Almost cheerful, honestly. Get closer, and the illusion shatters immediately. Io has over 400 active volcanoes erupting right now. Not historically, not occasionally, constantly. It is the most volcanically active body in the entire solar system. Some of its volcanic plumes shoot material up to 500 kilometers into space. To put that in perspective, that's farther than the International Space Station orbits above Earth. Straight up, lava, sulfur, and gas blasted into the void. So why is Io doing this? The answer is Jupiter. Jupiter is so massive, so gravitationally overwhelming, that it kneads Io like dough, stretching and squeezing it as it orbits. But Io is also being pulled by two neighboring moons, Europa and Ganymede. The result is a tug-of-war happening inside Io's crust, constantly. This friction generates between 60 and 80 trillion watts of heat inside the moon. For reference, all of human civilization currently uses about 18 trillion watts of power. Io generates more heat from being squeezed than we use to run the entire planet. And because Io sits deep inside Jupiter's radiation belts, the surface is bombarded with 3,600 rem of radiation every single day. You need about 400 rem to receive a lethal dose. Io gets 9 times that, daily. If a human stood on Io, before the radiation killed you, before the sulfur dioxide froze your lungs, before the 400-degree lava flows reached you, the sheer electrical current flowing from Io to Jupiter, a channel generating 5 million amps, would make Earth's worst lightning storm look like a birthday candle. The volcanoes resurface the entire moon to a depth of several meters every few thousand years. Io literally erases and rewrites itself on a cosmic timescale. There are no impact craters, because the surface is destroyed and rebuilt faster than asteroids can mark it. It is, without question, the most violent solid surface in the solar system. Now let's talk about something a little different. Not a moon that will kill you instantly, a moon that is, very slowly, dying. Phobos is one of Mars's 2 moons. It's small, only about 22 kilometers across, roughly the size of a city. It looks like a lumpy potato with a massive crater on one side. Unremarkable at first glance, but look closer at the surface. You'll notice something strange. Long grooves, parallel cracks, stretching across the surface like stress fractures on old concrete. Those aren't random. Those are stretch marks. Phobos is being pulled apart. Here's the situation. Phobos orbits Mars closer than any other moon orbits its planet in the entire solar system, just 6,000 kilometers above the surface, and it's getting closer. Every year, tidal forces from Mars drag Phobos inward by about 1.8 centimeters. That sounds tiny, but over millions of years it adds up. NASA has confirmed it's losing ground, or losing orbit, rather, constantly. In somewhere between 30 and 50 million years, Phobos will cross what scientists call the Roche limit, the point where Mars's gravity will exceed the forces holding the moon together. When that happens, Phobos won't crash, it will disintegrate. Mars will shred it into a ring of debris, which will then slowly rain down on the Martian surface over millions of years. So if humanity ever builds cities on Mars, and if we're still around in 50 million years, we'd have a front row seat to watching a moon die. And those grooves on the surface? Some scientists now believe they're not from asteroid impacts at all. They're early signs of the stretching to come. Phobos is literally showing us it's coming apart, one crack at a time, a moon quietly falling toward its planet, getting a little closer every year, never stopping. There's something almost poetic about that, or tragic, probably both. Here's something that keeps astronomers up at night. Every major moon in the solar system orbits its planet in the same direction the planet spins. That's just how moons form. They're born from the same spinning disk of material as their planet, so they go the same way. It's as natural as water flowing downhill. Triton, Neptune's largest moon, goes the wrong way. Triton orbits Neptune backwards, counterclockwise, while Neptune spins clockwise. No large moon in the solar system does this. None. And that fact alone tells us something deeply unsettling. Triton didn't form around Neptune. It came from somewhere else. Scientists believe Triton originated in the Kuiper Belt, that frozen, distant region of the solar system beyond Neptune. At some point, billions of years ago, it wandered too close to Neptune and got captured by its gravity. It's not a moon. It's a prisoner that never escaped. And now it's paying for it. Because of its backwards orbit, tidal friction is slowly robbing Triton of energy. It's spiraling inward, just like Phobos. In approximately 3.6 billion years, Triton will either crash into Neptune or be torn apart into a ring. But here's where Triton gets genuinely strange. Despite a surface temperature of minus 235 degrees Celsius, cold enough to freeze nitrogen solid, Triton has active geysers. When Voyager 2 flew past in 1989, it spotted dark plumes erupting from the surface, blasting nitrogen gas and dust up to 8 kilometers into the sky. The dust then drifted downwind up to 150 kilometers across the surface. Geysers. On a world colder than anywhere else we've visited. Powered, scientists believe, partly by the faint heat of the sun passing through Triton's semi-transparent nitrogen ice, like a cosmic greenhouse effect on a world where you'd freeze solid in seconds. Standing on Triton, you'd see Neptune hanging massive in the sky, rotating in what looks like the wrong direction. The geysers erupting around you. The cracks in the ice below you slowly deepening as the orbit decays. It's a world that's beautiful, bizarre, and absolutely doomed. Here's what gets me every time I think about all of this. We live on a planet with one moon. One calm, familiar moon that rises and sets predictably, that we've walked on, that we've named craters on. We look up at it and feel like we know it. But the solar system has over 290 confirmed moons, and many of them are nothing like ours. The universe is enormous, and it's full of moons worth being afraid of.